Hello everybody, and thank you very much for attending this webinar today. Just to let you know that you are all muted. If you want to ask questions, then there should be the ability for you to type in questions as we're going along. And if you type those in as we're going along in the GoToWebinar app, and at the end I will look to see if we have any questions and I'll answer them at that point. At the end, after this webinar, you'll receive a follow-up email and it will receive the information that was in this webinar, and you will be able to view this at a later date as well. So it is being recorded and will be made available through our website. Okay, so once again, thank you very much for attending. My name is Gavin Newlands, and today I'm going to be talking about modeling bolts and adhesive connections using Oasys PRIMER. So just to summarize, there are four main connection types in PRIMER. The first one is spot welds. So these are beam or solid elements that connect together shell parts and are most likely attached via tied contacts, so they're generally mesh independent. Then we have bolts, and these are rigid types of connections. So we have NRBs, nodal rigid bodies, or constrained rigid bodies, which connect together small rigid patches. And these can optionally include beams or joints. Then we have adhesive. So these are lengths or patches of solid elements that connect together shell parts via tied contacts. And then we have spot weld lines, which are similar to spot welds, but they are a way of grouping together spot welds and lines so that the pitch of those spot welds can be easily modified. And they can also be linked to a free edge as well, so that if your mesh changes, then your spot weld line will change as well. So today we're going to be talking about bolts and adhesives. For spot welds, that was the subject of a previous webinar, and if you're interested in that, you can look at it through our website. You can view that as a recording through our website. So first of all, I'm going to talk about bolts. So bolted connections, when you create them in PRIMER, are rigid type connections. And generally these can be categorized as either a nodal rigid body type or a rigid patch type. So here you can see in this top image, we're specifying 2 points that we want to create a rigid type connection. At the bottom here, we see the two different types that you can create. On the right-hand side, we have nodal rigid bodies that are being created at those points to connect together the parts that you see. On the left-hand side, you can see that some rigid patches have been created on the parts being connected together, and a constrained rigid body will be created between the rigid patches to join them together. This summarizes the types that you can create. So these are the simple types of bolts that can be easily created in PRIMER. So if we look along the top row here, we have 1-point cylindrical patches. So these are the types where we create rigid patches of shells and connect them together via constrained rigid bodies. Now, what PRIMER does is, if we have this input point here, so this is the coordinate that we want to create a connection entity, PRIMER will automatically determine the orientation of the surrounding panels, this green part and red part, and create a cylinder of a specified size, and then any shells that are within that cylinder will be added into the rigid patch. Once the rigid patches are created, it will create a rigid body merge between the two patches, and the connection will be complete. So going along the top line here, you can see some variations on the cylindrical patch. So instead of a constrained rigid body between the two patches, you can add a deformable beam. This is an example where you can add a spherical joint, or you can add a zero length discrete beam as well. So all these entities will be automatically created by PRIMER when you create the connection entity. The second row down here is very similar, but this is the nodal rigid body based ones. So instead of creating the rigid patches and the constrained rigid body between those patches, it will it will select any node that's within that cylinder that I mentioned before and add them into a constrained nodal rigid body. And again, we have the same options of creating a deformable beam, a spherical joint, or discrete beam as well, if you want to model your bolts in that way. This third row down is a slight variation on the cylindrical NRB, and this is a spherical nodal rigid body. So here, instead of a cylinder being centered around the specified connection point, we have a sphere, and any node that's within that sphere will go into the nodal rigid body. Then at the bottom here we have 2-point bolts. So these first 3 rows here are 1 point, so you specify a coordinate where you want to create the bolt, and Primer will automatically determine what's close by. The 2-point is if you want a little bit more control as to where the ends of the bolt are, so maybe slightly longer bolts. And here you can see you specify 1 point for the head of the bolt and 1 point for the tail of the bolt. And then you get, again, you get rigid patches or nodal rigid bodies at the ends, but then you connect them together with deformable beams or rigid beams or revolute joints or however you want to connect them together. So how do you create these things in Primer? Well, once you've read your model in, you go into Tools, Connection, Create. So there's a connection button in Tools. You click on Create, and you see this panel down here. The first thing you do is you select the shells that you want to connect together. So that might be some parts or just or the whole model you can select. Then you select the connection type you want to create. So in this case, bolts. This panel will then open up, the panel on the right-hand side, and this is the panel you use to create your bolt connections. So this is showing it for 1 point. You'll see slightly different information for the other types, 2-point, generic, and library. And I'll explain generic and library later on. So here we've got at the top here attributes. So we have bolt head diameter. So this is the diameter of the sphere that I was talking about. So you can change that to determine how big the bolt is. Bolt length as well, you can specify here. Creation method. So these are various different methods for creating this bolt. So if we just go through them, XYZ coordinates. So you type in the XYZ coordinate, the location you want to create this bolt. Screen point allows you to just click on the screen and a bolt will be created at that point. Single node, if you've maybe you have a node at all the bolt locations that you want to create, so you can specify a node. Edge of hole is quite useful if you're creating a bolt on holes in your mesh that already exist. You can click on a node on the edge of that hole and Primer will automatically find the center of that hole and use that as the input coordinate for creating the bolt. Between nodes is similar, where you can select any number of nodes and Primer will automatically find the central point and use that as the coordinate input for the creation of the bolt. And then pick connection as if you already have a connection entity within the model you can use, and I'll explain what that is in a minute. Another point for the edge of hole one is this shape control at nodes. So instead of specifying a particular diameter, you might want to specify that you always have 1 row of elements around a hole or 2 rows of elements around the hole that will be rigidified and form part of the rigid connection. So you can select those options here and Primer will automatically find those elements for you. So I'm just going to interactively demo this so you can see how it works. So if I just open up Primer, you should see Primer now, and I've got a very simple model in here. And this is part of a door structure where I've got a bracket here and a reinforcement plate on the back. So there's 3 parts. There's a dark blue part, the light blue bracket, and then the orange reinforcement on the other side. And I want to create some rigid connections through these parts. So I can do that through the connection tool. So if I go to Tools, Connection, Create, what do I want to connect together? So I'll just click what's visible. Connection type to create. I'll create some bolts. Click Next. And here you can see I get the panel that I've just gone through in the slides. So I'm going to create a 1-point bolt, and let's create some cylindrical patches to start with. So down here, Bolt FE method, I'll change to a rigid patch option. I'm going to specify that the bolt diameter is 15 millimeters. And I'm going to use the creation method of screen point. That allows me just to click on the location that I want to create the bolt. So if I zoom in, so I click here, hopefully you can see that Primer has created a visual representation of that sphere, and it's showing and highlighting the shells that are within the sphere and therefore that will be added into the rigid patches. If I want to create that, I just click Apply. And after clicking Apply, hopefully you can see these shells have changed color. So we've got blue here. If I look around the other side, you can see there's a dark red, dark orange on the orange part. That means that those shells are in a different part. Those are rigid patches, and they are connected together now by a constrained rigid body. So Primer will create the rigid shells on top of the current mesh, and also create the constrained rigid body to connect them together. So that rigid connection is now made. You can quite easily undo it. So if you click on Undo Last, it will remove those rigid patches and remove the constrained rigid body. I'm just going to try a different method now. So let's do the nodal rigid body type. I'm just going to make the cylinder a bit bigger, so 20 millimeters. Let's try 25. So now you can see there's a visual representation. It's showing me the nodes that are within that cylinder, and therefore the nodes that will end up being within the nodal rigid body. Again, I click Apply, and the constrained nodal rigid body has been created. I zoom out a bit. I can then quite happily click around my screen, creating bolts. I've created another one there. Quite easily create that bolt type again and again and again. There are other ways of creation. So this is a manual creation method. If I just dismiss that, I'm going to delete the connections that I have. And I've got a part of a vehicle model here, part of a body in white. You can also read connection information from files. So if I click on Read, I'm going to read an XML file, which is a Primer format. If I click Apply, just look at the screen, and you should see all the bolts that are referenced in this file being created automatically. Yeah. So there wasn't any bolts in there before. If I just zoom in to this location here, you can see that there are some nodal rigid body type bolts that are being created. And you can see the cylinders representations are in there as well. Let's go back to my slides. So once you've created bolts, so you can create them manually, or you can read some information in, so Primer can automatically create them. You can then manage that information and modify that information using the connections table. So the connection table looks like this. Essentially, you have one row per connection, and this can be used for spot welds, adhesive as well. Here we're looking at an example for some rigid type connections, some bolt type connections. And you can view all the information there is about these bolts and modify it. So you can see which parts are being connected by it, the diameter, the original coordinate, the type, and this can all be modified quite easily. So this slide shows an example of changing the diameter of that bolt from 20 to 40. I'm just going to show this in Primer. I've got an example of this. If I bring up my model again and go to connection table and bring up the connections table, here's a list of the bolted connections in the model. So if I just select a few of them, and let's change from 20 to 40, update and remake. So these cylinders you've seen have now got bigger, and there are more nodes within them, and therefore more nodes in that nodal rigid body. If I now change this back to 20, remake those. Now smaller again, less nodes. I just want to show you how easy it is to convert these from one connection type to another. So at the minute they are nodal rigid bodies, but I can change the type to a cylindrical merge, update and remake. So these are now rigid patch type connections. The nodal rigid bodies have been removed, and instead we now have rigid patches which are connected together with constrained rigid bodies. So it's a very simple and easy way of modifying your bolted connections in your model through some very simple steps. Now, here you can notice that you can still see this cylinder. So obviously when Primer is creating these connections, it's creating the dyna FE that's required to connect together the model. So the nodal rigid body, or the rigid patches, and the constrained rigid body between them. That's the dyna cards that are required. But on top of the FE, Primer also creates an internal entity type called a Primer connection type. And that's what you're seeing here. That's the cylinder there. So it remembers information that were used to create the connection, so that in the future you can then remake and modify them easily using the connections table. So each bolt has a corresponding connection entity which stores the instructions for making the connection. So doing this has several advantages. So one is that failed bolts are retained in the model and can be fixed at any time. So you might have read in lots of information and some of the bolts could not be made for whatever reason. Maybe the specified coordinate is not close enough to the panels to make the bolt. That connection entity will be retained in the model, and that means that you could look in the connection table and look at the bolts that have failed to make, and you could look at the panels being referenced and then modify and fix that connection. And when creating from a file, the original XYZ coordinates are retained, so that if you've maybe received information from an external source for the location of the bolts, that XYZ location is retained in your model. So it doesn't change as your model changes. And as I've shown, it's easy to change the bolts from one type to another. So I showed you changing nodal rigid bodies to rigid patches. And this all works with all the other connection types that are available to you, so spot welds, adhesives, and so on. So these connection entities, they are written out when you write the model out of Primer, but they're written after star end. So you write your model out and all your dyna FE is written before star end. The Primer internal cards are written after star end. That means that dyna doesn't use them and it won't complain because it doesn't read after star end. But when Primer reads the model back in, it will read these cards so that you have that connection information available to you, so you can modify them easily when you read the model back in. So this is an example of one of the cards for spot welds, but they look pretty similar for bolts and adhesive. And the associated FE entities are referenced so that Primer knows which to delete if the connection is being deleted or remade. So that's a key part of it. So one disadvantage of having connection entities is that confusion can arise if the connection entity itself becomes separated from the associated FE. And a common thing there is maybe they're split across different include files. By default, Primer will create connection data and the FE associated with it in the current layer that you have in Primer. But there are options on the connections table to manage the include file location of the connection data. And this is quite important with bolts, because if you're creating a bolt between two include files or parts that live in different include files, where do you want the FE and the bolt information to live? So, for example, with a constrained rigid body connecting together rigid patches, you would probably want the rigid patches to live in the separate include files, and maybe the constrained rigid body and the connection entity itself you would want to live in a sort of third include interface file that contains all the interface information between those two include files. The connections table has tools that allow you to apply that sort of modeling methodology to your model quite easily. Now, one thing you will probably come up against is that sometimes these types of connection are modeled not necessarily in Primer. You might be modeled in another preprocessor, and you come into Primer and you want to modify them. But if they don't have the Primer connection entity living on top of the FE, then you're not able to remake those and modify them easily. But in Primer, there's a tool called From FE. It lives under the connection panel as well. And what this allows you to do is to create the Primer connection entity on top of the FE that exists in your model, so that you can then go into the connections table and change the diameter of some bolts or change to a different modeling methodology. So you might have a model where all the bolted connections are modeled with nodal rigid bodies, and you want to change them all to constrained rigid body merge patch definitions. But you don't have the Primer connection entity that lives on top of it. You can use From FE to easily do that series of steps. I'll show you this a little bit later with the adhesive as well. But essentially, you specify nodal rigid bodies or constrained mergers that exist in the model, and specify that you want to create a Primer connection entity on top of those. And there's options for maximum size and so on, so that sometimes you might have bigger constrained nodal rigid bodies in your model that you don't want to class as a bolt. So the other bolt types on the panel, there's generic bolt. So these bolts are designed to give a more generic method for the two-point connections. And they can again be formed using nodal rigid bodies or rigid patches. And it gives you complete control over the panels that you want to join at each end, and also the orientation and size of the cylinder used at each end. So you can have independent cylinders at each end that determine what's within that bolted connection. So generic bolts are really for situations where you want much more control over how the geometry of the bolt is defined. And they can be useful in situations like this, shown in this image, where you have maybe some parts that don't quite line up as they probably should in reality, but you still want to create a finite element representation of a bolt in there. And so you can use generic bolts. You can see here there's a red cylinder and a green cylinder that don't line up. So you can quite easily use generic bolts to create this. Now, if you have a situation where the bolt types that are available in Primer are not what you want to model a more complicated model, have more information in that bolted representation, there is something you can use, which is a bolt library. So this is a very simple example here. Let's say we've got this green and blue part, and we want to create a bolt that connects together these green and blue parts at these orange dots, these coordinates. In our library, we have a file which contains a bolt. So a single bolt lives in this library entry, and that's a finite element representation of a bolt. And that can contain any dyna information you want. What Primer does is that each of these specified locations, it will read in the one bolt, it will import that in, it will renumber it, it will orient it so it matches the panels that it's being joined together. It can stretch it and connect it in so that this individual bolt model can be applied many, many, many times to your vehicle model. I've got a demo of this. So the starting point is you've probably got a bolt model. This is a very simple bolt model. As you can see here, I've got a simple bolt representation. Now, if you want to add this to your library, you go to Connection, Library. Now here you have to specify some information so that Primer knows the orientation of the bolts and where it's going to be connected and so on. So for the bolt head, you specify certain bits of information. For the bolt tail, you specify certain bits of information. Once you've done that, you can save it into your library. Now the library is just a directory, a folder on your system somewhere which contains individual files, each one containing one bolt. Now that library can live in different places, so you can have a central location that everyone has access to, so that all of your team can use the same bolt information. Or you can have something in your home area which contains your own bolt models for your own purposes. So once you've added your bolt in the library, let me read another model in. If you wanted to manually then import that into your model and create a bolted definition and attach it in, you can do so. So here we have a model, and let's say I want to create a bolt through this hole here. I can go to Connection, Create, select the parts I want to join together, create a bolt, and now I'm going to change the type to Library. So here you specify the end points of the bolt. So I'm going to do this by edge of hole. So let's choose the edge of hole here. And let's do the same on the other side, the other end. And now I'm going to select the library entry that I want to use. So I'll use M6 bolt down here. Click Apply. Let's do a contact fit. Click Apply. Hopefully you can see that Primer's read that in, oriented the bolt so it fits within that definition and attached in the ends as well. So this contact fit means it will stretch the bolt so that it fits right up to the surfaces. I'll just show you another example of this. So now I've got two panels, an orange panel and a blue panel. And there's various holes in here when I want to create some bolt definitions. And I can do Connection, Read. I'm going to read some bolts from an XML file again. So let's just do that. So this has created 4 bolts. Hopefully you can see them there. I'll just make these panels transparent. I'll zoom in a bit so you can see those bolts there. So that's created 4 bolts. And what it's done is that library individual file read in 4 times, translated, oriented it, resized it, and attached it in at those 4 locations. Now, one of the powerful things I can do now is if I go to the connections table, in the connections table, I can change these bolt definitions to something else. So these are all these M6 bolt.key. If I right click, choose another bolt from my library, I don't know, let's see what this one does. Right click, update and remake. That's read in a different bolt definition and attached it in. You can see them there. Let's change to a different one. Let's try this one. And hopefully, you might not have seen it on the screen there, but when it reads it in, you can see the end of the bolt moving as it stretches and compresses to make a good contact fit with the parts that you have there. So all 4 have been changed to that definition, but you can easily do this with more than 4. You can do this with hundreds, thousands of these bolts. So quite easy to change the modeling methodology for all these connection types in the connections table. Okay. So I'm going to move on and talk about adhesive now. So with adhesive, Primer can create 2 main adhesive types. There's a line adhesive. So this is a row of solid elements of constant width, which are projected to the panel, panels being joined together. And then we've got patch adhesive, which are generic patches of solid elements, which again are projected to the panels being joined together. And they're usually created by projecting shell elements to the panel surfaces that are surrounding. So I'll just show you some examples of these. This is line adhesive. So you can see the adhesive here. We've got this green panel and blue panel that we're joining together. And these red outlined solids are the adhesive solids that are being created. And the adhesive path, so basically the path of these solids, so you can imagine a line going down the middle of these solids down here. The path can be created manually, so you can click on the screen along here, click, 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 click to define the path. It can be created automatically from free edges, so you can select the free edge of this green part here to create the path on the flange along here. Or it can be created from geometry lines. So if you have information in IG's format, you can read that into Primer and use the lines to form these rows of elements. And you specify the number of elements across the width, the element size along the length, and the adhesive path width. And then that's all the information you require. And then Primer will create those solids by projecting up to the attached surfaces to create the run of adhesive. So I'll just demo this. So here we have a B-pillar, simple B-pillar model. I'm going to blank some parts. So I've just got 2 parts here. And I'm going to, it's the same as in the image, I'm going to create some adhesive along this edge here. So I go to Connection, Create. Let's select Visible for the shells I want to connect together. And I'm going to choose to create adhesive. So I need to specify a part ID. Adhesive width, let's keep that at 10 millimeters. Number of solids across the width, let's change that to 2. Element length, let's draw 5 millimeters. And I'm going to use the free edge method. And this means I'm going to select some nodes on the free edge. And Primer will walk along around the free edge between those 2 nodes and create a path on the flange. Yep, so this is just sketching what the solid elements will look like. I can change the distance away from the edge. At the minute that's 1 millimeter, so let's change that to 3 millimeters. Resketch that. See, it's now moved in away from the edge. And I can change these parameters here and keep on sketching it until I'm happy. And then when I click Apply, those solids will be created. So hopefully you can see those solids are being created by projecting up and down to the panels I want to join together. Okay. There's another interesting creation method here, which is an automatic way. So it's a useful tool if you don't have any information to hand as to how these parts will be glued together. What Primer does is it automatically looks at all the free edges and the selected parts and then creates adhesive based on those free edges. So if I click on Auto Adhesive, I'm going to select a master part here. So this green part. I'm going to sketch the adhesive. Excuse me. So you can see now along all the free edges it's created paths of adhesive. You can see it's also created them around some of these holes. You can change some of the settings here to remove these. So there's a minimum run length here. So if I increase the minimum run length value and sketch the adhesive. You can see it's removed the ones around these holes. Now I can just click apply, and the adhesive is created automatically there along the free edges. So it's quite a useful way of automatically creating adhesive if you don't have any information to hand for how they're going to be connected together. Okay. Now, you can also use the From FE feature in Primer for cases where you have some adhesive solid runs in your model and they're being created somewhere else outside of Primer, but you want to modify them. Okay. This is a similar situation with bolts where you have the FE in the model, but you don't have the connection entity that exists that's created when you create the entities in Primer that allow you to modify easily. But you can use From FE for this. So I'll just show you an example of this. I read in the model. So here I've got a model that doesn't contain any Primer connection entities, but does have some runs of solid elements here. So if I go to, I'll just zoom in a bit more so you can see these. If I go to connection from FE, and now I'm going to select some adhesive. So I'm going to choose all the solids in this model. Click apply, click continue. What Primer has done now is it's created on top of those solids a Primer connection entity. You can see those green lines that are on top of the solids. Now this means I can now go into my connections table and change information related to this connection. So let's say I want to change the number of elements across the width from 1 to 2. And let's say I want to change the width from 5 millimeters to 10 millimeters. Update and remake. So hopefully you can see that the width of those solid adhesive runs have now doubled in size. If I blank the parts, you can see there's now 2 elements across the width instead of 1. So the From FE feature allows you to very easily create Primer connection entities on top of solid elements in your model and then modify those adhesive runs. Okay. Now, in the same way that you can modify information through the connections table for bolts and spot welds, you can do that for adhesive, and I just showed you how I did that. One other thing you can do in the connections table when modifying adhesive paths is you can change the path itself. So if I go to back to that model, zoom in on this one here, it's the first one on the list, I can edit the path. So I can sketch that, this is the path here, and I can modify any point in that path. I can add, I can remove points in that path. So let's say if I want to change the start point to be over here, update and remake it, you can see that's now extended the start to the end of the panel. Now the other type of adhesive you can create is a patch adhesive. So this isn't a constant thickness run. This is when you want to spread adhesive over the entire surface area. This example here is a whole flange. You want to spread the adhesive out, and usually this is created from source shells. So you select shells and you want to project those to surrounding surfaces. So adhesive patches are solid elements created between shell parts where the source of the projection is shells. It's easiest to demo this as well, so I will do that. Select this model. and I'll rename this model. It's the same as the example that we were just looking at. So let's say I wanted to create adhesive between this bottom surface of the blue part and the red part underneath. I go to Connection, Create. Again, select the parts I want to join together, and I want to create adhesive. So now my creation method is patch. Again, I need to specify a part to create the adhesive in, so let's just type one in there. But now I need to select the source shells. So here I'm just going to select the shells using Viz feature line that lie on this surface. So I've selected all the shells on that surface. Apply selection, click apply. Hopefully you can now see that those solids, the yellow solids, have been created, projected up and down to the surface, and quite easily made. Now, I should point out that with adhesive patches, if I go back to that model, again, Primer will retain a connection entity, but the source shells don't necessarily have to be in the model that you're creating the adhesive. So one common occurrence is that you get the excuse me, the adhesive information as maybe CAD ribbons. You can mesh those, and then they can be read in the model too, and they can be used as source information to create, to project up and down to the panels you want to join together in model 1. So that's the way sometimes they can be used. Okay. Now I mentioned this in my spot weld talk, but it's worth mentioning again now because it relates to adhesive as well. So when you're creating adhesive, these solids are mesh independent. They're not meshed into the panels they're joined together. So you need to use a tied contact to tie them to the panels. Now you can do this manually if you wish, but there is a tool in Primer to automatically create and check the tied contacts. So you go to Connection Contact and you'll get a panel that looks like this. And here you can check to see which nodes within the adhesive are tied and which ones aren't. And you can also fix the problems. Now, usually the problems would be maybe the connections have not been remade correctly and you've replaced a part or something and the node now lies off the surface, so you can fix those. But another common problem is that with a tied contact, you can either have a constraint-based contact or a penalty-based contact. And the constraint-based contact are the best ones to use, but if you have a constraint-based contact that ties a node to a surface, if you have any other constraint definition in that area, so you might have a nodal rigid body or constrained rigid body merge, that can cause a constraint clash, which means that the node is not tied. But you can fix that with Primer. So basically Primer will, clicking on the create connection contact here, Primer will automatically create the required contacts for you, create a slightly different contact for solid elements and beam elements. But once they're created, to sort out this constrained clash problem, it will do one of two things. If you're running in versions of Dyna less than R7, then it will create two contacts essentially, a constraint version and a penalty one that live on top of each other. And what happens in Dyna is that if the constraint contact doesn't work because of a constraint clash, then the penalty one, the penalty contact will pick that node up and make sure it's tied. In R7 or greater, there's actually in Dyna there's a flag that will do all that internally. It's called IP back, and if you set that on, then internally within Dyna, a penalty-based contact will be used in parallel with a constraint-based contact. So Primer will automatically set that flag if that is the situation in your model. But it's a really useful panel for checking the contacts that you have in your model and also fixing them as well by making sure they're correct and making sure everything is tied. I just wanted to mention scripting because there's quite a powerful scripting tool within Primer for doing various things. So it's got an embedded language that allows you to access data in your model and also to modify and create data as well. And it also gives you access to quite a lot of the Primer functionality, including connections, so bolts and adhesive. So for connection, scripting can allow you to read and write connection information in any text format. You can create connections from information in the files that you read automatically. So maybe there's connections that exist in a file format that Primer doesn't natively read. You can fairly easily create a script that will read that file and grab the information required from that file and then automatically create the connections that you need, so it be it bolts or adhesive or spot welds. You can also modify connections according to company-specific rules, so you might want to modify part IDs or material properties of elements depending on how many panels are joining together. You can do all that via scripting quite easily. So we're just getting to the end now, so just a summary of what I've talked about today. So there's various bolt and adhesive types that can be created manually easily using Primer. They can also be created using various automatic methods, such as reading from a connections file or creating using free edges, for example. The Primer connection tool can be used to modify existing connection information that was not necessarily created in Primer, so you can use the From FE tool. Primer connection information is saved with the keyword deck to allow you to allow easy modification in the future. Excuse me. So the Primer connection entity that is created, I talked about creating this connection entity on top of the FE that's actually created. That can allow you to easily modify, manage, and check the connection information through the connections table. It's also worth noting that other tools within Primer know about connections. So an example here is part replace. If you're replacing a part, then Primer knows what connections are attached to that part, and it knows that the mesh might change, so it has to remake those connections to attach to the new part that you're bringing in. So using connection entities within Primer allows you, also feeds into all the other features in Primer, and when using those features, it helps maintain the integrity of your model. Okay, so that brings me to the end of the webinar today. So first of all, thank you very much for your attention today. I'll just check to see if we've had any questions come through. No, we haven't had any questions come through. If you do have any questions on this subject or any other subject, please feel free to contact us. So our support contact information is on the screen now. So please do contact your local distributor or contact us directly, and we'll hopefully answer your questions about bolts, adhesive, or any other question you have on Primer or the rest of the Oasys software products. So once again, thank you very much for your attention, and we'll bring the webinar to a close now. So thank you very much. Goodbye.